Hey, hello, welcome back to the channel. Welcome to Space Engine. I don't really know what I'm going to do here. All I know is that this game, if you want to call it that, has a stupid amount of content within it. Accurate content, and I want to explore it because I'm a space nut, and I just want to see what I can find. I want to see what we can discover together. I love space, like, astrology, astronomy, the hypothetical what-if questions about, other stars and galaxies and habitable planets and all these things. I've always been a huge fan of them. And Space Engine and Universe Sandbox are two of the most awesome games out there that you can own in order to really, expand upon that and kind of indulge yourself in it in a creative way. So here we are, Space Engine. I don't know how to play this game. You don't really play it, I don't think. You just experience it. I don't know. Anywho, let's just jump into it. I don't know what continue means. I don't know what that's going to take us to. I haven't done anything except adjust the settings a little bit, like as far as audio. So let's just see what a planetarium tutorial, huh? Okay. Interface, basic movement, free movement, time control, universe map, system chart, star browser. Oh god. So yeah, there is a lot to this, isn't there? So let's just see what it does. Does it just throw us into our solar system at the beginning, or planet RS8496 2265-8-11? Wow. Okay, so apparently this is, I think this is our time, right? I don't know. Cool, so I think it honestly did just send us to a random star RS8496. It's a red dwarf. That's neat. That's cool. Wow, so there is a lot of stuff. Oh yeah, my mouse apparently goes off the screen. That's a little annoying, but whatever. Wow, so it right off the bat, huh? It sends us to a terrestrial planet. Oh, temperatures in Kelvin. I don't know if I want the temperature to be in Kelvin. I don't know how to read Kelvin. I'm sorry. Oh, here we go. Here's the temperature. 105 degrees Celsius. Okay, so this planet, 105 degrees Celsius, really? And it has water on it? Seriously? Oh, God. It does. Maybe I'm looking at the wrong planet. I'm not so certain any planet... Oh, wait, that's the greenhouse effect. I'm sorry. No, the greenhouse effect. Yeah, temperature, 105 degrees Celsius. That is extremely hot. Wow. Okay, so this is... again, I'm jumping into this, like, out of nowhere. I don't know... Okay, that's how you pause time. Oh, wait a minute. Okay, so that's my velocity. So that means I can... Oh, I get it. Yeah, okay. So the higher my velocity, obviously, the quicker I move in space. That'll get me out of the planet. This planet actually has rings on it. We can probably look at some of these rings if we get closer, maybe. Here we go. Of course, the rings are mostly just meteorites and debris and stuff like that that's orbiting around the planet. Kind of like how... I wonder how fine the detail gets on those. Looks like it's kind of just something along these lines. So here's one of its planets, or here's one of its moons, I should say. Of course, the moons don't have names. Temperature on this moon is a negative 138 degrees. That's a little cold. And there's a nebula. Okay. All right, let's see what we can do here. Real quick. Let's just... Let's see if we can just go to Earth. I do know how to do that much, at least. Here we go. Whoa! And slap. Here we are. Okay, so here is our lovely little ball of atmosphere and water known as Earth, and if I wanted to, I think I could even, go kind of where I am right now. I believe this is the continental, United States. I don't know how to rotate the screen very well, but I think this is North America. I can't really tell. It looks like North America. We could, let's see. How do you fast forward time? That's not it. So anyways, interesting stuff here about the planet already. We are a temperate marine terra with life, which means, you know, marine terra means we have water and we have, you know, earth. We have actual ground and there is life on the planet. Obviously, I'm sitting here running my mouth. You know, the average temperature on Earth is 15 degrees Celsius, which is like, I think, like 50 something degrees, like 55 degrees Fahrenheit. 4.5 billion years old, I believe. Axial tilt of 23 degrees. Parent size, we have one mass of Earth, which you can view this mass in another way, I think, but I don't know exactly how. No, let's see. Here we go. Go to object, land on object, browse planetary system info. Here we go. Here we go. Here's Earth. Okay. So yeah, here's some information that's interesting. I think this is mostly what you see on the side of the screen already. Our atmosphere extends 114 kilometers in the air. That's pretty neat. Our greenhouse effect is 33 degrees Celsius, which is very warm, which is probably why, you know, we're not a snowball. And here is what the atmosphere is consisted of: mostly nitrogen and oxygen with trace amounts of argon, I think. Argon? I don't know. I'm not sure. I'm kind of a dumbass, really, to be honest with you. And here's our orbit. This is what I like, this stuff right here. So, a really cool thing about our orbit, you know, the Earth doesn't have a very eccentric orbit, which is why, you know, we don't, we kind of orbit the sun on a level plane, unlike certain other planets, like I think Uranus and Neptune. Let's see, Roche limit for satellites is 9,488 kilometers, which I think that means if a satellite like our moon is any closer than that, it will eventually start to tear apart because the Earth is kind of eating away at it, I think. I could be completely wrong here. So what is this? Universe map, wiki, main menu. No, go back. Here we go. Solar system chart. Okay, cool. So this kind of moves things around for us a little bit. Here's our wonderful sun, a yellow dwarf, thank goodness. It is one mass of the sun, which I don't have anything to compare to at the moment. 13, one planet with life. Gravity of 27.922 grams, I'm guessing, I'm not sure. Anywho, we can zoom on in here. Here's lovely little Mercury, which is the same size as our moon almost, except, you know, more massive. Here's Venus. Everybody loves Venus. Could totally have life on it if it wasn't, you know, a living hellscape. Here's our planet, the Earth. This is a terrible video so far. I'm just kind of digging around. Cool, arid subterra. Mars. The temperature on Mars is only -50, which is not, you know, terribly cold. We have Ceres right here, dwarf planet, which is roughly this, you know, it's like, what's the size of Ceres as far as mass? I wish I could view the mass in a different context instead of, because you can make the mass appear as you know, something else. And here's its orbit, obviously. See, it's a little eccentric as well. It doesn't really spin perfect. Let's go back out. All right. Then we have Jupiter, the bringer of jollity. Ah, yes, Jupiter. Where's that big red spot at? I don't see it. I think it might actually be, yeah, there it is. There's a big red spot, which I think they say is dying right now, slowly. And of course, Jupiter has a ridiculous amount of moons. I think Jupiter, these are only the main larger moons around Jupiter. There are far more. Yeah, there's 79 moons around Jupiter, and even more around Saturn. Here's Saturn. Look at the Look at the ring shadows. Those are so cool. Let's see here. I know I can kind of adjust things to a degree. It's really tricky. I should probably have practiced more off camera. How many moons does Uranus have? 27. And of course, Uranus is a little funny planet with its orbit. This is not accurate. I think Uranus actually orbits on its side. Then there's Neptune. Then you have Pluto and Charon right here. Which, fun fact about Pluto and Charon, which Pluto isn't a planet, but they actually share a noticeable barycenter with each other, I think, which means that they orbit around one another while also orbiting around the sun. Then we've got Haumea, yeah, Makemake, Eris. I've heard of Haumea. I don't know if I've heard of Makemake, and Eris I have heard of. And I don't think it's going to show us anything else. Let's see. Let's hop out of this and go back. What's this? Spacecraft Manager. Journey log. Locations. Display. Settings. Okay, real quick. Let's just look at this. Nickname. We might as well just give ourselves a proper name. Interface skin is flat blue. That's fine. Jupiter, Neptune. Screenshots format. 3D backgrounds. Units of measurement. Here we go. I'm okay with light years and astronomical units being my medium distances. Let's do the temperature in Fahrenheit just because does that save? Can I reach? Okay, I think that will, yeah, that automatically updated. Okay. I think. All right. Yeah, okay, that was an immediate update. Controls. Main menu is escape. The console is tilde, which I don't really think I want to use. I probably should have went over this all ahead of time, but let's see. Star browser, filter objects, controls, music player, add point. Here we go. Decelerate time speed, K and L. Okay, so that's one thing I really want to remember. I want to make sure that we can speed up and slow down time while we're looking at things. To check out orbits and whatnot. Map and chart controls, there's many things that I would have to study up on here in order to properly understand this. So, but just to put it in perspective, that would be our sun right there, correct? No, that's the moon. I'm sorry. Okay, let's back up a little bit. Here we go. Okay, so that is our yellow dwarf sun right there. And we can really just zoom away from it if we want to, huh? Now, some of these objects, some of these stars that are moving pretty quickly, that are close to us, have to be some of the closer stars, like Alpha Centauri or whatever. I wonder what this one is. That's Sirius, Canis Majoris, Gliese. Okay, I think there's. Let's actually go here and see what we can see. So we know what's around our galaxy, or solar system, I should say. Oh God. Okay, you should probably just use the go-to function when you want to travel to stars, because, oh God, yeah, it's, let's see, here we go, go-to object. Boom, there we go. Let's slow down a little bit here. So this is, Sirius A star. That's pretty neat. And it's gone. Oh me, this is nutty. Back up. We gotta slow down. Here we go. Here we go. This is better. Let's see if we can get a better look at this star, huh? Once we get close enough. Ah, there we go. Okay. So it's a white main sequence star. Man, it's creepy looking, isn't it? Talk about creepy. Whoa, it's bright as hell too. Let's see if we can speed up time. So I could have sworn that there was a button that would do this for me. Or a scale. There we go. Okay, so there is Sirius A star. Now, where can I view the planets on here? Solar system browser. I would assume that there would be a list. Let's see here. Planets. Here we go. Planets. No, I wanted to say, I don't want to disable them. I want to view them. Come on. Help me out here. Spacecraft. Markers. Orbits. There we go. Okay, orbits. That'll help. That'll help us find some planets around this star. So let's see what we can... Let's see what we can discover around Sirius A star. This is obviously one of the closer stars to us. Wow, this is disorienting. Here we go. Kinda, I think. I don't know. Up. Let's see. Let's go up here. Here we go. Now, where is this closest planet at that's orbiting around Sirius A star? There it is. Okay, so here is the closest planet to Sirius A star. This is Sirius B. Is this a star? I think this is another star. So this must be a... what's the term for... What is the term for it when two stars orbit? It's a binary system. There we go. I don't know what that is. Stellar barycenter. Oh, that's the barycenter. Okay, so yeah. So this is a binary system. And the barycenter is essentially the point between these two stars, right in the middle of them where they're orbiting. And I would assume that if the barycenter is closer to this star, then that means this star has a larger mass. A mass of 1.264 compared to Sirius A star, which is 2.1. Okay, so Sirius A is obviously the more massive star, more massive star. Now, if this is a binary star system, then I would assume it's highly unlikely that there is going to be any planets in orbit around these stars, because it's super difficult for planets to stay in orbit around... Oh, we got time going too fast, don't we? Oh, slow down. Here we go. Okay, God, you have to really slow down when you get close to these planets. Here we go. Yeah. I almost feel like, seriously, I almost feel like the lens flare is a little too much. Hang on, let's see if we can... Here we go. Oh, bloom and glare. There we go. Let's turn the glare off real quick. And the lens flares. Just for fun. And let's see what it looks like now. God, we're on the fucking plate. Stop, please. God, I'm gonna vomit. Get off the planet. Get off the star, please. Oh, God. Go away. We gotta get off this planet now. Or we gotta get off the star. I'm not about that life of sitting on the face of a star and rotating a bajillion miles an hour. I don't really know if it really changed much, though, huh? Let's see. Let's turn the glare black. Let's turn the glare back on. I'm gonna leave the lens flare off, I think, and just for fun, we'll put the graphic settings on ultra because I know I can handle it. Oh yeah, okay, that's what I want to disable then. Ugh, yeah, screw that. I'm sorry, but I feel like the glare is just ridiculous. We'll leave the lens flare on though. I don't know what these mean. Classic, maybe. Here we go. I almost feel like the bloom is a little too much. What if we turn the bloom off? What does that do? Ooh. That makes it creepy. It's a white dwarf, so I guess we are seeing more of what the planet, or what this star would actually look like. You know, to a degree. Not really sure how, you know, how much bloom would be a good setting to have. And I don't really know what, yeah, I don't really know what that does, but like the lens flare is classic. I don't really know what. Fire in the hole. This is I feel like this is just kind of the fun thing here. Orbit marks, orbit trail links, thickness, major bodies, tone mapping, saturation and brightness. You know, all these things. There's so much to keep track of. I mean, look at all this. It's crazy. It's crazy how much work they've put into this. So let's just back out for a second. All right, so here is the current system we're looking at here. I don't know what that is. Orange giant. Oh, no, that's not what I wanted to look at. All right, so yeah, this is what I was talking about here. So Sirius A and Sirius B orbit around one another because they're binary stars. You know, this is what would happen if our sun was close enough to another star. It would be orbiting around it. So watch what happens. What am I locked onto? Just a random star. Watch what happens when I speed time up. This is how these two stars go throughout space together. Come on. You've really got to speed... Oh, I'm paused, aren't I? There we go. And even with time, like this is millions and millions of years passing right now, what you're seeing, like what you're watching. But do you see how these two stars... actually, let's focus on Sirius A. There we go. Oh, well, we're still not focusing on Sirius A, I guess. Yeah, we are. Let's just back up a little bit more. There we go. So, this is how these two stars travel throughout space. They're technically massive enough to orbit one another. But the point, there's an invisible point in the middle here, this barycenter, which I clicked off of again. But there's the barycenter right there that they share. And obviously it's going to be closer to the larger body because it has a higher gravity, a higher mass. And like I said, I can't imagine there are any planets at all around these two. And I actually don't... I don't think you can place planets in this mode. You know, this isn't... you know, this is not Universe Sandbox. So to pilot ships. Oh God, no, I am not ready for that. I don't think, as far as I know, that I could... Oh, damn it. I don't think that I can place an item. Ooh, what did this do? Universe map, huh? This is creepy looking, isn't it? This really does just kind of zoom you out. Gives you a, this gives you a more, I guess, kind of just, less glamorous, but more statistically accurate view of what you're looking at. Kind of takes away the background a little bit. So, let's see. And again, I do apologize for not really knowing what the fuck I'm doing. It's just, I'm just playing around, you know. So, there's the barycenter. Here's Sirius A and here's Sirius B. These are the only two... This is it. There's nothing else in this star system because there can't be. There can be nothing in orbit around these two stars. It's impossible. The way that they orbit one another is so ridiculous that they would fling out anything that tried to get near them. The only thing that could come into orbit and stick into orbit around these guys would be another star that kicks one of them out. Because I don't think it's possible to have a triple binary system, or a trinary system, I guess would be the correct terminology there. And that's how you go faster and slower. All I had to do was click down here. So, let's see here. Free mode, spacecraft mode, go to object, land on object, center object, track object. Cool. So let's click off of that. Oh, that's the button I want. If you click on that twice, oh, it brings that down. And this shows you all the... This is what I was wanting to look for earlier. Okay, I'm figuring it out. I am figuring it out. Okay, so... One more thing. Let's go back to Earth real quick. And this should adjust here and take us, and it should have our sun and then the other planets around it. Here we go. Boom! There we go. Whoops, I didn't mean to pause time though. So, oh, it didn't adjust. Let me just click on the sun then. No. No. Sun! There we go. Okay, so now if I click on this, yeah. Now it is going to show some of the dwarf planets. I can take those out. Gas giant minor moons, no. Real sizes, no. Okay, so we're back around planet Earth as we do, and let me speed things back up a little bit so we can check out what we can check out. I wonder what that is right there. What is that? Oh, wait a minute. Is that the... No, that can't be what I think it is. Is that the... Okay. You see this? This arc right here. This is, I believe, the Berry Center. It is, isn't it? Yeah. Okay, that's the Berry... Jesus Christ, this is hard to maneuver. Slow down. Okay. What you see right here inside the planet is the Berry Center that we share with our moon. Our moon is so massive that we technically share an orbit with it. Although the Berry Center is inside the planet, it's not in the middle of the planet. It's, towards the surface. That's crazy. Our moon is that huge. I wonder if we go, real quick. If we go to Pluto real quick. Oh, well, yeah, Pluto's not on here because Pluto's not a planet. Let's go to Pluto real quick. I want to see the Berry Center that Pluto shares. Yeah, it's a lot larger, isn't it? The Berry Center that Pluto shares with Charon, I think, its moon, right? These orbital lines need to go away. They are ridiculous. I think how did I bring those out? I need to remove those. Show orbital lines. Where was it? Oh, they're over here. That's right. I think planets, nebulas, clusters, stars, galaxies, spacecraft. I'll find it. Give me a second. Comet trails, clouds, water, auroras, constellations, orbits. There we go. Okay. So, of course, that makes the point I'm fixing to prove harder to prove. There's Charon. Charon, I think, is actually the name. So there's Pluto and Charon, which is pretty neat. Let me turn that back on. I don't think there's any way to edit that. But see, look, Charon is actually so large that the Berry Center for it and Pluto is off the body of the planet, whereas the Berry Center that the Earth shared with Pluto, with Mars, was in the planet. Charon is pretty dang big compared to Pluto. So, when you speed up time here, do you see how Pluto's kind of orbiting in a circle? It's orbiting that midpoint there as they're kind of orbiting each other. So, while Pluto and its moon orbit each other, they're also still orbiting the sun, which, by the way, is just ridiculously far away at this point. Like, it's stupid. Stupidly far away. So much so that, if we were to travel to the face of the planet of Pluto here, let's see. How do you... Here we go. Spacecraft mode. Land on planet. There we go. Oh, God. Stop. Okay. Boom. This is what you would see from the face of Pluto. Now, I don't necessarily know how true it is. I don't think that the sun would really be that bright, but I also don't know that it wouldn't be that bright because Pluto doesn't have an atmosphere. It doesn't have any sort of, greenhouse. It has nothing. Look at the temperature on Pluto. It's negative 385 degrees. No life could possibly ever survive on this planet. And I'm left to wonder if I were to turn the bloom off. Nope, that didn't do anything. Turn the lens flare off. I don't think that did anything either, did it? Nope. Still awful bright here on planet Pluto. I feel like the sun wouldn't be this bright, but I could totally be wrong. It is right now for us, but I don't know if it would be, Oh, classic. Oops, sorry, I didn't mean to do that. Classic. Lens flare on. Glare. I might, you know, screw with this a little later. I feel like the gamma might be a little high, honestly. I don't know. I do like the background music. So, yeah. Anywho, pretty neat. Oh, you can see that same nebula from here. The Carina Nebula. I wonder if we can see any other nebulas from the face of Pluto out here. It doesn't seem like it, but... yeah, you never know. I wonder what all these planets are. Cluster Pleiades? Pleiades, I think? I don't know. I don't know exactly. So, yeah, I definitely need to screw around with this more often. You know. Let's see. Let's crank up the velocity. Ooh, this is super fast here. How many astronomical units away from the sun is Pluto? I forget. Oh, well. It's far. And as you can see, as I move here, these closer objects that are moving, like right there, I'm going to guess that's either Jupiter or Saturn. That's Jupiter. So that would mean that this is probably Saturn right here. Yep, that's Saturn. Let's see. There is also a dot right there. That's probably Earth. Nope, that's Venus. Okay. The Earth might be on the opposite side of the sun here. It's kind of hard to tell. There's Earth. Yep. And that would be Venus. That's Mercury. That's Venus. Cool. Look at you. Oh, God. Look at Jupiter. Go flying by. Oh, God. There we go. Hey, Jupiter. What's going on? Let's unpause time and let Jupiter spin around for us. Oh, God. I'm going to vomit. Let's slow down time and let Jupiter spin around a little slower. I think there's probably a way to to focus lock yourself on the planet. I'm sure it's down here somewhere. Reverse time speed, you know. Set current time. I don't really know what that means, but center object. Yeah, I don't know what that means. Track object. Oh, maybe that's what we have to do. God, I'm sorry. I didn't mean to. All right. Well, that's still, either way, we got our feet wet, and that was the main idea. You know, there's so many things to explore in this game that it's crazy. Like it's infinite. You know, the things that we can discover here and look at and kind of, you know, track and check out. Now, I don't know if it's I don't know if this is actually if this is accurate or not. Let's see. Because it's kind of got the Earth tilted here, you know. I want to say that from space, the Earth is actually upside down. I don't know why I'm focusing on that. It's from where you drag it from. Okay, that makes more sense. That makes all the sense in the world. Okay, I got it. It's still fucking... This is really, really, like, crazy hard to finagle. I promise I'm not, like, trying to make it impossible to look at. It's just... It's really tricky. Here we go. Alright. Yeah, see, we are... we are sideways as hell right now. Oh, we can rotate with Q. Oh my god, that makes it so much easier. Okay, god, that's what I was hoping for. Let's see. Okay, so yeah, here we go. This is more what I was hoping for. Kind of. Come on. Let's keep going up. Oh god. It's so tricky. I promise you I'm not doing this on purpose. Pause time. Okay. We're going to try to land where this video is being recorded. To a degree. Apparently, there is a hurricane still in moderate shape over what looks to be Ohio and Michigan. So take that. Oh God, take that with a grain of salt. Anywho, let's see here. Yeah, here we go. Okay, we're gonna do this. We're gonna do this. Shut up. This is how we're gonna end the video. We are gonna. Okay, I don't know where Kentucky is exactly, but god dang it, we're gonna land there. There we go, right here. And I think we're in the planet now. No. Come back out of the planet. We are in the planet, and I can't. I've fallen in the planet, and I can't get out. Help me. Help me. Oh, God. Let me out of the planet. I'm stuck. We are forever buried in Earth, apparently. All right, that didn't go as well. All right, anyways. This has been one episode of... Ooh. What is that? What galaxy is that? That's a star. I want to look at the galaxy. Large Magellanic Cloud. Okay, cool. I've heard of that. I wonder what this one is. Small Magellanic Cloud. Okay. Cool. Take a quick gander. One more small gander. I wonder if that is the Andromeda Galaxy as a whole. I don't think it's possible to select the Andromeda Galaxy as a whole. That's probably not it anyways. I don't really see anything else super amazing. Look at all these pulsars, I think. Are these pulsars? No, these aren't pulsars. Per se. Man, there's so many of them. I wonder what that one is. That one's close. Calf. There's a galaxy. Andromeda! Hey, I did find Andromeda. You know it's Andromeda because it's like the only galaxy you can make out. You can actually see the shape of it. I'll tell you what, I'm going to call it here, and I think we're going to mess around with this in the next episode. I'm probably going to play I'm going to play around with this for a while. We're going to just see what we can find, and we'll go from there. So yeah, thanks for watching.